here we just have 5 over x, so Gracie was using, I think, the smallest triangle, right? And putting hypotenuse over longer leg. And then she said, okay, then in the big triangle, I also have to put hypotenuse over long leg. And so she put hypotenuse over the longer leg. Your proportion could be slightly different, right? The numbers could be arranged in different positions. As we know that there's lots of different ways to write the same proportion. But when we cross multiply and solve, you should get 4.6. Does anyone have a question for us? Okay. All right. So we're going to move on now and look at the rest of this section. We have a couple of more theorems to look at. We actually have 3 more theorems to look at right now. And you can close your books. Well, if you'd like to, you can be following along. We're going to be on page, what does it say up there? 452. Okay. You want to have your book and follow along in. Everything I'm doing up here, we will eventually get this up on Moodle, so don't feel like you have to copy every little thing. Okay, rather that you're paying attention, focusing, asking questions, understanding what's going on, rather than worry about copying every little detail. These theorems are in your book. And again, I'll post this on Moodle so that you have reference to it. So let's get going. Okay, so here we have another theorem that seems like a mouthful. Remember yesterday we had to read the theorem like 3 times to start to understand it? And today I've tried to highlight some of the main terms to help those stand out for you. Can we get a volunteer reader? Thanks.
Less of the altitude geometry with right angle to the alternatives of the right triangle, the geometric mean of the length of the sequence into each of the altitudes divided.
Okay. So there's 3 words that I've highlighted in red there. Okay. And do we all know what I mean by altitude of the triangle? The same as yesterday, right? The altitude drawn from the right angle to the hypotenuse. Okay. Geometric mean. We reviewed that yesterday, right? What it is and how to find it. So we should be okay with that. The thing we might need to talk about a little bit is, I've highlighted this term segments. Now you know what a segment is in general, of course. But what we need to do is make sure you know how we're using this specifically in this theorem and the next 2 theorems. And what it means is this, is that when we draw the altitude, the right angle of the hypotenuse, it hits the hypotenuse at a certain point, right? And so that altitude essentially divides the hypotenuse into 2 segments. So these segments are B and C, which I've labeled here. It's the segments that the hypotenuse is divided into by the altitude. Is that clear to everyone? And in most cases, when we do that, you can see that we get a shorter segment and a longer segment. What would be the only case when we don't get a shorter segment and a longer segment, when the segments are the same? What kind of triangle? An isosceles triangle. If we have the right angle at the top of an isosceles triangle, then when we draw the altitude, the segments will be the same. But the theorems still work. Okay? So we usually will have a shorter segment and a longer segment. And we're going to use that terminology. We're going to talk about it that way. In fact, that terminology will appear in the next theorem on the next page. Okay? So everybody's okay with the idea, the concept of the segments that we're using? Fine. Okay. So we also know that geometric mean, when we reviewed it yesterday. So tell us again, what's the definition of geometric mean? Maybe use GM. No, we'll go back and use X like we always do. How do I find the geometric mean of 2 numbers? We had this definition up there yesterday. Square root of? Okay, the 2 numbers, AB, right? And but where do we say that came from? X squared. Square both sides, we have X squared equals AB, right? And let's go backwards one more step. a what? A proportion. This came from the proportion A over X equals X over B. Good. Okay? So when we talk about geometric mean, yes, we can calculate it this way, but we also want to be thinking about this proportion that has the geometric mean in these two key spots, right? It's the means, right? The denominator of the first ratio and the numerator of the second ratio. And so that's why you can see I started to set up a little proportion here. Okay? And we're going to fill that in and show how this theorem works. And so if we think about what we learned yesterday about our three triangles, put this one here. And let's put this one here and rotate it. So now we've got three triangles. And what do we know about these triangles? What's the relationship between them, among them? They're similar. We just got finished doing some exercises with that, right? That was the last theorem we did yesterday. Three similar triangles. Okay, so let's take this A, B, and C and let's label our smaller triangles. So this shorter side of the purple triangle is what length? What should I label that with? B. It's this segment right here, right? It's the shorter segment. Ooh, what happened here? That's not supposed to do that. We changed something here. Infinite cloner. Infinite cloner. You know what the infinite cloner is? You ever seen an infinite cloner at work? Oh, infinite cloner does this. It's really cool. Okay. Somebody with us? And this side over here of the purple triangle is which segment? It's A. Okay. Now, in the yellow triangle, the base here of the yellow triangle is which length? It's A. It came from over here, didn't it? And this side here? C. Very good. Okay. So now we've labeled these two triangles. And we know that they are what? What's the relationship? Okay, so we should be able to make a proportion from their corresponding sides, right? Okay. So let's start with B. Let's start with the short leg of the purple triangle, right? So that's B here, right? So let's put that up here into our ratio. And let's put the short leg over the long leg. You with me? Short leg over long leg. Okay. So on the other side of our proportion, we also have to do short leg over long leg, don't we? Okay, what's the short leg of the yellow triangle? It's A. So short leg over long leg. And there's the proportion that results. And do you see the geometric mean appearing there?
Yeah.
What's the geometric mean? Which letter is the geometric mean? Oh, the geometric mean itself is just A, right? If we cross multiply, let's see, make sure we see that here. So we've now got B over A equals A over C. When we cross multiply, A squared equals BC. When we take the square root of both sides, we get A equals the square root of BC. So we can see, we've kind of proven, not a formal proof, but we've proven this theorem and demonstrated what it says. It says that the altitude, remember these A's were originally the altitude, that it's the geometric mean of the segments from the hypotenuse of B and C. So far so good? So we can use this to solve problems if we have an unknown. If we have something that looks like this, and if we know two of the three values, you'll see some exercises like this. You have to practice this skill. If you see two